So this is example number 3. It will be on plane stress. So in this particular example, let's consider the following case. Example number 3 on plane stress. Let's consider the following state of stress. First of all, as a reminder, a plane stress is confined to a plane. Okay, so if it's confined to the XY plane, your state of stress is going to look like sigma XX, sigma Y, tau XY, sigma YY, with all these 0. Okay, if it's confined to the YZ plane, your state of stress is going to look like this. And if it's confined to the XZ plane, it will look like this. Okay, so they are all examples of plane stress. In this particular example that we're going to do is confined to the YZ plane, and your state of stress has the following values. It is 0, 0, 0, 0, 0, minus 20, 30, 30, 0, KSI. Okay, so before we start the problem, and I want to go ahead and draw these elements, what they look like. They will look something like this. We are confined to the Z plane. Your Y goes in this direction and your X comes in this direction. So what you can see, this is in the Y surface in this direction, and it will come like this. This is 20. This is acting in the Y in the Z, positive Z. So your shear will look like this, always opposite. And you don't have stresses perpendicular in the Z direction. Okay, so this is what your state of stress in the drawing will look like. Let's assume that your this is your body's in equilibrium, and for the theory, you may want to review section 3.5 of the text, especially figure 3.8. That might be very, very helpful. Okay, so to solve this problem, what we can see is that sigma XX is equal to 0, sigma YY is equal to minus 20, sigma ZZ is equal to 0, tau XY is equal to tau XZ is equal to 0, and tau YZ is equal to 30. Okay, so in order to solve this, let's go ahead and use our MATLAB code for this. We're going to run this. So when we run it, this is in inches, it is KSI. This value is 0. This value is minus 20. This value is 0. Y, X, Y, and X, Z are 0, and Y, Z is 30. Okay, so this is what your Mohr circle will look like for this problem. And what you can see is very interesting in this problem, that your maximum critical shear happens in the compressive direction. So this problem is compressive driven more than tensile driven. So that's important. So the answers that we get from this problem are, this is your principal state of stress. So running your MATLAB code from MATLAB, you get that your sigma 1 is 21.6, sigma 2 is 0, sigma 3 is minus 41.6. Remember that for plane stress, always at least one stress will be 0. Okay? This is given by the fact that R sigma 3 is equal to 0. Okay? This concludes example number 3.